So, have you heard about this new CLAMS system from XTG2009? It's like a generative chemical language model that can actually decode molecular structures from raw spectroscopic data.
Yeah, right. It's built to interpret IR, UV-Vis, and NMR signals, isn't it? And what really stands out is how it generates SMILE strings directly from the raw data.
Exactly, yep. The approach throws out the old clunky case systems, which were always bogged down by scalability issues and computational complexity.
Yeah. And the secret sauce here is the hybrid architecture, right? Combining a ViT and ChemBERTa model trained on, like a massive dataset, over 129,000 molecules.
Correct. That's what allows it to predict structures in just seconds. It's like a turbocharged AI laboratory that can spit out multiple candidate structures using
Exactly.
top K generation.
I find that really neat. Having that top K mechanism really boosts its flexibility and confidence in its predictions. But don't you think it might run into issues with like less common chemical motifs?
That's a fair point, but they validated it across a broad chemical space using something called the QM9S dataset. So even if it faces edge cases, its accuracy benchmarks apparently beat traditional methods.
Interesting. And then there's Deep Covalent's DMGPS platform, right? It focuses on property-driven generation to design new drug-like molecules without relying on established chemical scaffolds.
Absolutely. It's like reinventing the whole playbook for de novo drug discovery. Instead of just tweaking known compounds, it can generate novel ones from scratch, which is super exciting for pharmaceutical innovation.
Yep, sounds revolutionary. Now, I do wonder, don't you think with these kinds of models, there's a risk of over-reliance on data-driven predictions without enough chemical intuition built in?
I get that concern, but the integration of deep learning with traditional chemical knowledge seems to strike a good balance. It's like using AI as an assistant, not the sole decision maker.
Right, fair enough. The session, from what I gathered, was a real eye-opener in terms of how generative models can shift the paradigm, from strict rule-based systems to more dynamic, learning-driven approaches.
Totally. It's helping chemists to not just read spectra, but to actively decode them with unprecedented speed and accuracy. And the whole system is so scalable. Imagine processing thousands of compounds in a fraction of the time.
That scalability is key, especially for large-scale drug discovery projects. It sounds like a real breakthrough that could shorten the development cycle significantly.
Exactly. It's like a high-speed express lane in chemical research. You just feed in the raw data, and within seconds, you have a suite of possible molecular structures. And that's a huge leap from the old methods.
Yeah, absolutely. I also like how the model offers flexibility in interpreting spectra by using those top K predictions. It adds a layer of confidence checking that could be really useful in research.
Right on. And while some may still be cautious about fully replacing traditional methods, the blend of deep learning and chemical intelligence here paves the way for more innovative approaches in molecular design.
Indeed. All in all, this CLAMS approach represents a shift towards more adaptable and intelligent chemical elucidation tools that could redefine how we approach organic compounds.
Indeed, it's an exciting time in chemistry and AI, redefining the frontier between computational predictions and experimental realities in an almost seamless way.
Absolutely. The future of chemical research just got a whole lot more dynamic, and I can't wait to see where these innovations lead us.